Hi everyone. Okay, in this Coding Bytes, I'm going to be talking you through the PlayStation 5 controller, how we interface, how we link this with TwinCAT using ADS, very similar to our Xbox code that we did before. And this is going to be a couple of parts, I'm going to assume. So I'm going to do the first video, which will follow this, which is just me running through what this controller can do. Very, very, very good controller. The second part of the video series will be how I did it. So how it all comes together. What tools did I use in TwinCAT, what I did in TwinCAT HMI, how I embedded things like the scope view, we've got a 3D model, and then I'm going to end it with how you set up the Python, what the Python's doing, what it's doing via ADS. Okay, all right, speak to you soon. Okay, right, swapping over to the controller's camera now. I'm just going to take you through the basic functionality of this, and this controller is very, very good. I'm impressed by it. There's a lot of features on here that I like. So just running through the basics, we've got access to each of the buttons. That obviously returns back as Boolean. The D-pad we have access to. We get analog values back from the joysticks. Plus as well we get Boolean from their press state. We've got a microphone button and a PlayStation button just down here. We've got options and we've got share. We've also got the left and right bumper. And we've got analog values coming back from both of the triggers. The thing that this thing's got as well, which I would say puts it over and above the Xbox controller, is we get a trackpad. Now this trackpad is able to tell me where my position lives with an analog value. This is quite a high resolution analog value as well. And so it gives me live feedback of where my finger's currently pressed. And you can see here, no matter where I can lift my finger, I can put it down, it knows where my finger is as I make contact with this touch area. Now, it also gives me two sets of these values. So if I have a finger down already, and then I touch a second finger down, it reports that back by a second set of analog values. So I can actually do two finger tracking, and these are completely independent of each other as well. So that's ideal. That's really good. So I'm sure that can be utilized in an application as well. Again, it's up to your imagination, really. I'm sure we can build in things like gesture controls. You could maybe have people sign for things. So who knows? Who knows what way we go? The other thing as well, it's got a push button. So if we press this center area, it acts as a push button as well. So ideal. That is really, really good. I'm really impressed with that. Next thing that we get motion feedback. Now, I'm showing this using a 3D model. And the reason behind this 3D model is to show that we can embed 3D quite merrily in TwinCAT HMI. Because again, TwinCAT HMI, it's using web-based technology, HTML, CSS, JavaScript. If you can do something in a web browser, you can do it in TwinCAT HMI. You just bring in whatever library you wish to use. So what we can see here, so these are two sets of three values we have. So the first one, it has an inbuilt gyroscope. So we can, at the moment, I'm only, I think I'm doing the roll and the pitch, I think I'm doing, just off the top of my head. There is a third axis that it's giving us, and that third axis is actually telling us if the controller's upside down or not. So at the moment, I haven't implemented that. I don't want to spend too long just doing the 3D model. At the moment, this does everything you'd expect it to do, but if you're holding the controller the correct way up, if I turn it upside down, you'd see the model actually stays the right way up. So again, this is an open source project. If someone wants to add that, feel free, go for it. The other thing that you'll see too is that we're getting feedback coming back with the internal accelerometers. So if I try to single my movement down to just a single plane, you can see this motion here. This is coming up on this green axis, which is what they call the x-axis. I have a tilt side to side. And let me just flatten the controller out slightly because you're seeing that on both at the moment. And because the scaling, it's auto-scaling. All right, it looks like it's on the blue. Yeah, it's actually the yellow one that's doing this one here because this is detecting a side-to-side motion, where if I hold it like a steering wheel and steer it like a steering wheel, you'll see here that the blue is now the biggest value. So blue is doing rotation in this direction. Yellow is the accelerometer in this direction. And green is in this direction here. So that's ideal as well. Perfect. Plus as well, what you can see here, this is TwinCAT scope embedded into TwinCAT HMI, which we'll run through in the coding session. Next, settings. There are a few settings. Now, this is what I've done is I've exposed the settings that are available by DualSense, the Python library that I'm using, which has been put forward by Flock. Now, some of these features, I think some of these features are still being investigated, so there's not the full documentation here of what everything does, but obviously with a certain amount of trial and error, you'll be able to discover things that are working, and hopefully they come through on the camera well. I'll see if I can just tilt this slightly so we can see it. So we have access here to all of the different colors, and this is just a slidable RGB value that we can do, so all the way from our red into our blues. So that's possible to do. So again, if you're looking to indicate maybe a warning to the user or something that they're trying to control hasn't, maybe it's not yet taken effect, and we just say no. Currently, this isn't in remote control mode. Maybe move it into green to say, yep, you've got control of this. That's definitely possible. We have access to the player indicator lights. So if you see here, we've just got these two lights. So that's number 1, number 2, number 3, number 4, and we can actually just tell them all to turn on as well. This set of options here is, say, somewhat obscure. It's not too bad. With options turned off, you don't get control of any of these. These don't work. So what we need to do is, if we can speak to the player LED, which is the little dots down here. You have to have that selected on player LED, and then we get the ability to go from low, medium, and high. I mean, there's only a small change on the controller that might not even come through on the camera, but we have ability to change the brightness there. The other thing that we can do is swap it to light bar, and now we can force it to fade into blue and fade out. So, and hopefully you'll see that there, it fades out and it fades back to its standard color. So they've clearly built in that feature to auto do this. There must be something related to blue that they want to have fade in, fade out. And again, fade off, that just means that's now disabled. If you tick both, you can now control the LED's brightness and activate this fade. So I don't really know why you'd want to switch these at the moment. Leave them on both, and this is then, because fade at the moment, fade is only working on the light bar and brightness is only working on the player. So yeah, I'm not too sure with that, but anyway, this isn't really a deep dive into how the controller's working. It's just to help you use this demo and why these things are here. Okay, so I'll just set them back to off. The other thing that I've got access to is the left and right motor for this haptic feedback. Now, originally, when I looked at this, I thought, oh, okay, we've got a left and a right vibrate. That's not the case, because when you start the vibration, again, just slide it up, and the controller itself, maybe if I put it on the desk, you might start hearing it. So put that up. So you've got a low rumble, and you've got a high-pitched rumble. So these are actually, they vibrate the entire controller, but they're clearly weighted differently. So the right-hand side is a much lower frequency rumble, and this is the intensity of it. Plus the left-hand side is a much higher frequency rumble. And then when you combine the two, you can get some quite interesting sort of combinations of haptic feedback coming through. Okay, so that's worthwhile experimenting, but it's definitely not left and right, as in left-hand side of the controller, right-hand side of the controller. And we have the ability to mute and unmute the microphone that's in here. And plus as well, we get access to the LED. You can just see the LED down the bottom here. Switching on and off too. So we've got an extra little light on here. Depending on the order that you do these, the way I've coded it up, the LED control will always win. If you just use the mute control, and you'll see the code in the background, if you only use mute, when you mute, you will actually get the light come on and off as well. It's just I'm taking control of the LED over the top of what its mute state is. So I can actually have it muted and the LED off if I'd like, because I've taken control of it. So that's available to you. Last, what we're going to speak about, these triggers. These triggers are great. Really, really, really good. And I'm sure that you can have some fun setting this up. So in their current state, and this is going to be hard for me to put through on a camera, but I'll do my best just talking through. Currently, the feeling of this trigger is what you would expect on a standard controller. There's a little bit of resistance there. It feels springy, but we have this, it's not haptic feedback, it's feedback on the trigger. We can make the trigger feel like something. So the first setting we have is rigid. So when we enable rigid, you'll actually feel that the trigger changes. So now when I compare the two, I've definitely got some opposition to my finger. It's actually restricting me how I pull this back. And we have the ability to change some of these settings. Now, I believe, and again, this is only through experimentation, because until the documentation comes available, this is only what we're discovering. And the first slider, because we've got 7 settings here, but not all 7 settings relate to the modes we can set. This one is the position that you want the trigger to go rigid, and this one here is the intensity of how rigid you want the trigger to become. Really good. So setting it here, I'm saying that at the maximum, so in other words, I want the full travel to be as rigid as possible. That's now a really hard trigger to pull. So you could kind of use this, because let's say, for example, you were bringing something in and maybe the trigger itself was activating some form of gripper. If you've got sensors on your gripper to show that you've actually made contact with the thing you're picking up, why not move this feedback position? It's very fast as well. It changes its position really quickly in here. So at that point, as someone's pulling the trigger to grip, you could give them feedback to tell them that they've actually made contact with the thing they're picking up. So really good. Experiment with it. There's so many things that we can do with this controller. Pulse. This one, from what I understand, this is going to be where the resistance comes in and where the resistance drops off. So this one here, now as I'm feeling it, it kind of clicks now. So I've given it like a little area where I say, no, I want to have resistance here. And as I fall off the back of that resistance, it goes light again. There are a few others, and again, have a little search around. What I'll do is I'll keep adding to the repo. Anytime I find any more information on these modes, I'll just keep the repo up to date. The other thing that I found is Pulse B. This one here, at a certain position, I can set. This one actually feels like the frequency, and you might hear that come through the speaker. This one is saying at a certain position, I want you to vibrate the trigger. So again, even things like this, it's all about feedback, everyone. I mean, haptic feedback and controller feedback, it's all about helping our users. When we program, it's about helping the users of the machine or the equipment you're programming to understand it more, to get feedback. I mean, this is the whole thing. This is feedback. Use it, because you may find it's these types of feedback that come in that make your operators more efficient. Because ultimately, if they're doing something, if they're controlling something, and maybe as they start coming out of a zone, you start to rumble to indicate that they're starting to get into an area they shouldn't be. If you start showing them colors to show that their controllers are connected or that the product is ready to be picked up. If you give them feedback on their triggers to indicate if they're doing well or if they've come up against opposition, it's all good stuff. This can only help people. As long as it's consistent. I wouldn't just throw things in for rumble's sake. Oh, it rumbles because of this, it rumbles because of that. And you make too many things do the same thing, because just bear in mind, I see that a lot with lamp towers on machines, that the lamp towers themselves end up confusing people. There's too many lights, there's too many things going on. Keep it simple, keep it consistent, and I think you're going to have a really, really good setup with this.